So guys, now having understood the concept of paging, now we are in a position to revisit again and revise the memory allocation to a process. So operating system allocates or free memory to or from a process in the units of page size. Now throughout this course we have assumed that the size of a page is 4096 bytes. So operating system always allocates or free the memory to or from the process in the units of page size. That is, operating system assigns or reclaim back virtual memory in the units of 4096 bytes. So now it seems a little contradictory. So if your process invokes, for example, malloc 12, that is, your process is trying to claim 12 bytes of memory from the operating system. So the question is that does operating system allocates 12 plus MBS bytes. Now what is MBS? Recall there was something called meta block, right? So if you have gone through the section of heap memory management, you should be able to recall that operating system allocates you an additional memory called meta block along with the memory that is requested using malloc function, right? So I expect you that you recall the concept of meta block. So going forward, suppose your process requests 12 bytes of memory to be used from the operating system. So your operating system allocates 12 plus meta block size bytes of memory, or as I said in this point, that operating system allocates page size bytes of memory to the process. So we have a question that how much memory is actually assigned to a process. So the answer is the operating system allocates the page size amount of memory to be used by the process, but out of these 4096 bytes, only 12 plus MBS bytes of the memory is actually allocated to a process to be used. So now let us dive deep into this and see what actually happens. So when your process requests 12 bytes of memory using malloc function, operating system allocates 4096 bytes of virtual memory to your process, right? So allocation means that the heap segment is extended by amount equal to 4096 bytes. And as soon as your operating system allocates virtual memory, it also creates a corresponding physical page. And out of those 4096 bytes of memory, only 12 plus MBS bytes of memory is assigned to your process. So the amount of memory that is remaining is page size minus 12 plus MBS. And this amount of virtual memory is cached by glibc malloc implementation. That is, the malloc function actually stores the virtual page that has been assigned to your process. And from that virtual page, only 12 plus MBS bytes of memory the malloc provides to your process to be used. So suppose the diagram on the right hand side of the screen represents a virtual page which has been just assigned to your process. So the size of this virtual page is 4096 bytes, right? And out of these 4096 bytes, 12 plus MBS bytes of virtual memory has been used to satisfy malloc 12 request. And the remaining portion of this virtual page is still available to be used. So next time when a process requests more memory, say it invokes malloc 20, right? So malloc checks that if it has a virtual page which has unassigned virtual addresses to meet the new request. If yes, then 12 plus MBS bytes are assigned from remaining portion of the virtual page, right? So suppose the process invokes malloc 20, right? And you can see that malloc function still keeps track of this virtual page and finds that it still has a lot of space to be used. So the malloc function will again allocate 20 plus MBS bytes of virtual memory to your process. right? And this 20 plus MBS bytes of memory will be assigned from the same virtual page. So the malloc function will continue to assign memory to your process until this virtual page is completely exhausted. So after satisfying malloc 12 and malloc 20 requests by a process, memory that is remaining in a virtual page will be equal to page size minus 12 minus 20 minus 2 into MBS bytes in a virtual page, right? So this is the amount of memory that is still remaining. And in case virtual page do not have enough memory left to satisfy the process request, malloc request operating system again to assign another brand new virtual page altogether. So a diagram worth 1,000 words. So let us discuss all these points with the help of a diagram in the next slide.